All right, so the next topic we're going to cover is volume of solids. This is just a general quick overview of the two basic ways that these problems can be presented to you and the different solutions that we'll detail in other examples. So, volumes of solids in the textbook that we use is Chapter 7. It's usually one of the last sections covered in AP calculus before the AP. It is for us, certainly, and I think for most schools as well. So there are two basic ways you can see this problem presented. Either from defined cross sections, and the big hint that that's what's happening is you'll see the word cross sections in the problem. They will specifically define a kind of cross section and they'll use the word cross section. As an example, cross sections perpendicular to the x-axis are squares. So you can't miss that it's a defined cross section problem because they will use the word cross sections and they will define a shape like squares or semicircles or equilateral triangles. The second way that you can see a solid created is created by revolution. So this usually involves taking some shaded region and revolving it about an axis. So for example, the shaded region is rotated about the x-axis. Find the volume of the solid created. So based on the equations that you're given and based on the kind of shaded region, this could require one of three solutions. The solution methods that you'll see are called the disk method, so that's A here. The washer method, which is essentially just a disk with a hole. So if you understand the disk method, you'll be able to do the washer method. And then thirdly, the shell method. Now, the shell method is no longer featured on the AP exam in 2020, but we're going to learn it anyway for a number of reasons. One is because knowledge is good and learning stuff is good. And another reason is because at some point mathematically, there are some problems that you simply can't do with the disk or washer method. And having the shell method as something else that you can try is worthwhile in case you aren't able to solve it with disk or washer. Again, not necessarily on the AP if they're not testing that, but just later in your math or other academia career. And then the third reason is because when we do practice problems for the AP, we usually use old AP practice problems, and older methods do use the shell method. So I don't want you to be trying to do a problem and feel completely stumped only to find out that it only was doable by the shell method, which I didn't teach you. That would be a bad version of me doing my job. So I'm going to teach you the shell method anyway.